There are these creatures that came from off-world. These are untouchables. NASA, notable for its fundamental openings, has without a doubt uncovered that this new planet isn't simply beguiling, considering the reality of its size and district, but in addition, thinking about the truth that it shows lights that have every appearance of being artificial. Are we on the verge of uncovering insider truths that could change our perspective on the universe? Could this discovery eventually mean there is life on other planets? Join us as we explore NASA's fascinating revelations and uncover the truth behind these mysterious lights. In 2007, NASA launched the first light rocket with a mission to explore the most intriguing objects in our solar system. Dawn was equipped with 3 ion engines, allowing it to embark on an extraordinary journey. Dawn's mission began with a 14-month investigation of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data, revealing Vesta's enigmatic surface and diverse geological history. After completing its primary objective at Vesta, Dawn embarked on the second, and perhaps most captivating, part of its mission, a close examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and set out on a journey to reach Ceres, an achievement that traditional chemical propulsion would have found challenging. These engines, providing a steady, gentle thrust, enabled Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. First discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, and one of the most intriguing, due to its unique characteristics. As Dawn approached Ceres, scientists eagerly anticipated the first detailed images of this mysterious world. What they saw were bright spots scattered across its surface, most notably in a large depression now known as a crater. These bright spots sparked immediate interest and speculation among researchers. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Scientists knew little about this dwarf planet, and the opportunity to finally get a close-up view was exciting. What secrets would Ceres reveal? What new discoveries awaited? Dawn's mission promised to enhance our understanding of the solar system's evolution and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appear to be composed of highly reflective material, possibly salts left behind by sublimated water. This raised the possibility of cryovolcanism on Ceres, a process where volcanoes release water or briny fluids instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres? Could they be evidence of ongoing geological activity, or something even more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt due to its size, mass, composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a composition more similar to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015. This milestone marked a significant achievement in the mission, as Dawn was able to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn moved closer, the images of Ceres became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The first images revealed a surface pockmarked with craters, indicative of a long history of impacts. However, it wasn't just the craters that captured the attention of scientists and space enthusiasts alike. Among these features were unusual bright spots that stood out sharply against the darker, rugged terrain. As the resolution of the images improved, speculation about the nature of these bright spots intensified. Were they patches of ice reflecting sunlight? Or could they be something even more intriguing? Theories range from mineral deposits to possible signs of cryovolcanic activity. Closer analysis revealed that the brightest spot was not a single feature, but rather a collection of several distinct regions. This discovery only deepened the mystery. The hypothesis that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of transporting water or briny fluids to the surface, where they quickly evaporate, leaving behind bright, reflective deposits. These findings challenged existing theories about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raises the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres so significant compared to other planets? Ceres is a fascinating world, often described as a cold planet with a harsh yet delicate surface. Unlike most asteroids in the belt, which are primarily composed of rock and metals, Ceres stands out due to its unique composition. Its surface is a mix of water ice and hydrated minerals, including clays and carbonates, giving it a significantly lower density than its neighbors. This composition suggests that Ceres contains a substantial amount of water. The surface layer is rough yet porous, with ice and other volatiles trapped within. This cold characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that may have involved a combination of rocky and icy materials. Delving deeper beneath its surface, Ceres reveals even more intriguing aspects of its structure. The dwarf planet is believed to have a differentiated interior consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This mantle, possibly a mixture of rock and salty water, surrounds a core that may be composed of denser material, possibly silicates. The presence of such a large amount of water ice suggests that Ceres may have once harbored liquid water, especially if its core was heated by radioactive decay in its early history. This internal structure sets Ceres apart from its asteroid neighbors and raises fascinating questions about its potential for geological activity and the role of water in its evolution. The implications of Ceres' unique structure and possible geological activity extend far beyond its status as a dwarf planet. If Ceres still possesses subsurface pockets of liquid water, it could be one of the most promising locations in the solar system for studying prebiotic chemistry or even the possibility of microbial life. The idea that Ceres might have retained liquid water beneath its icy crust aligns with discoveries on other icy worlds, such as Europa and Enceladus, where subsurface oceans are thought to exist. While Ceres may not have the same vast, global ocean, its potential for localized briny reservoirs raises exciting possibilities. The mystery of the bright spots. One of the most intriguing discoveries made by Dawn was the bright spots in a crater. Initially, their origin was unknown, sparking wild speculation about everything from ice geysers to extraterrestrial signals. However, further analysis revealed that these bright patches were composed of sodium carbonate, a type of salt that likely formed when briny water from below the surface seeped up and evaporated. This finding was groundbreaking because it suggested that liquid water had reached the surface relatively recently, in geological terms. If Ceres is still experiencing occasional briny eruptions, it could mean that some form of internal heat source, perhaps residual radioactive decay, remains active. Additionally, scientists discovered that the haze above the bright spots in a crater changed with time, hinting at possible sublimation or outgassing processes. This further reinforced the idea that Ceres is not a dead, frozen world, but a dynamic body with ongoing activity. Could Ceres support life? While Ceres is unlikely to host complex life forms, its conditions make it an intriguing candidate for studying the potential for habitability in the asteroid belt. If salty, liquid water still exists beneath the surface, it could create an environment where microbial life, similar to extremophiles on Earth, might survive. Scientists are particularly interested in the presence of organic molecules detected on Ceres. The Dawn spacecraft confirmed the existence of carbon-based compounds, which are key building blocks for life. Combined with water and a potential heat source, This raises the possibility that Ceres may have once supported simple chemical reactions necessary for life's emergence. The future of Ceres exploration. Although the Dawn mission ended in 2018 when the spacecraft ran out of fuel, Ceres remains a prime target for future exploration. Scientists are eager to send new missions, possibly even landers or drills, to investigate its subsurface and determine whether liquid water still exists beneath its crust. Some proposed missions include Ceres Sample Return Mission, a spacecraft that would land on Ceres, collect surface material, and return it to Earth for analysis. Cryobot Explorers, robotic probes that could melt through the icy crust and explore underground reservoirs. Orbital Radar Mapping, advanced radar instruments that could penetrate the surface and provide more details about Ceres' internal structure. As we continue to explore our solar system, Ceres stands out as a crucial piece of the puzzle in understanding planetary formation, water distribution, and the conditions necessary for life. Could Ceres one day become a stepping stone for deeper space exploration? If humans eventually establish outposts in space, the water ice on Ceres could serve as a valuable resource for fuel production, life support, and scientific research. A new perspective on the universe. The discoveries on Ceres challenge our traditional views of asteroids and dwarf planets. Once thought to be barren, lifeless rocks, these celestial bodies are proving to be more dynamic and complex than ever imagined. Ceres, with its water ice, salt deposits, and possible subsurface briny pockets, is a reminder that the universe is full of surprises. As technology advances and our ability to explore deep space improves, we may soon unlock even more secrets hidden within Ceres and beyond. Could similar processes be occurring on other dwarf planets? Are there even more undiscovered worlds with conditions that could support life? Only time and future exploration will tell. Anyway, that is not all. The revelation of smelling salts muds on Ceres proposes that the Bantam planet might have formed in a colder part of the solar system before relocating inward. The presence of ammonia lowers the freezing point of water, supporting the possibility of subsurface brines. These insights into Ceres' structure and history not only improve our understanding of this fascinating dwarf planet, but also provide critical clues about the processes that govern the formation and evolution of icy bodies throughout the planetary system. Cryovolcanism is an intriguing and somewhat unusual geological process, especially when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, expel volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the extremely cold conditions where cryovolcanoes are found. On Ceres, cryovolcanoes function by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it rapidly evaporates, transitioning directly from a solid or liquid state to a gas, leaving behind bright, reflective salt deposits. These salt deposits form the mysterious bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in an area referred to as Spot 5. This region has drawn significant attention due to its high reflectivity and the unusual clouds observed by the Dawn spacecraft. These clouds are believed to result from the sublimation of water, suggesting that cryovolcanic activity might still be ongoing or may have occurred relatively recently. Moreover, Ceres has several other bright spots, each with unique properties. These spots are not confined to a single region, but are distributed across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the remarkable nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The outer surface of Ceres is pitted with various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an ancient surface subjected to numerous impacts over billions of years. Others are better preserved, with sharp edges and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is lower than initially expected, which could suggest that geological processes are resurfacing the planet, erasing evidence of older impacts. One theory is that Ceres' icy surface allows for a type of cryovolcanic resurfacing, where subsurface materials occasionally rise to cover older features. This ongoing geological activity suggests that Ceres is not a static world, but one that has been, and may still be, actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of fractures, ridges, and faults on its surface. These features indicate that Ceres' exterior has experienced significant stress and stretching. Some of the fractures appear to be relatively young, possibly only a few 100 million years old. Such features imply that the dwarf planet has undergone episodes of internal heating, likely caused by radioactive decay or tidal interactions with nearby celestial bodies. This combination of features, bright spots, craters, and surface deformation, suggests that Ceres has undergone a complex history of geological processes, including the potential for both past and ongoing cryovolcanism. These discoveries are not just significant for understanding Ceres, but also expand our knowledge of planetary evolution and the potential for life beyond Earth. Could Ceres' icy surface and subsurface water hold the key to extraterrestrial life? The evidence remains inconclusive, but it is clear that Ceres is a world full of surprises, with mysteries still waiting to be uncovered. In conclusion, the bright spots of Ceres offer a fascinating glimpse into the complex and evolving nature of this dwarf planet. With its potential for cryovolcanic activity, subsurface water, and geological activity, Ceres is more than just a frozen remnant of the early solar system. It is a dynamic world that challenges our assumptions and opens exciting new avenues for exploration. As the Dawn spacecraft continued its observations, it may yet reveal more secrets hidden beneath Ceres' icy surface. The journey to uncover the mysteries of Ceres is far from over. Though the Dawn mission has officially ended, its legacy lives on. Scientists continue to analyze the data it collected, and new discoveries may still emerge, offering fresh insights into the nature of this dwarf planet. The bright spots, cryovolcanic activity, and complex surface features observed by Dawn challenge our assumptions about how celestial bodies evolve, particularly in the cold, distant regions of our solar system.